Good morning. Well, today is what I hope is an exciting day at Khan Academy. We're going to kind of start a new set of, I guess we could call them lectures. But what we're going to do is I'm actually going to work through just a bunch of SAT problems. So what this is going to be is like SAT prep for free, or Princeton Review, or Kaplan for free. And I hope neither of them sue me for using their names. But anyway, what I want you to do is, if you haven't already, I want you to buy this book right here, the official SAT study guide. Let me make sure it all fits into the. You'll see it in the bookstore. And I hope I'm not doing any kind of copyright infringement. I'm not a lawyer, so I don't know all the rules. But I'm pretty sure, as long as I give them credit and that that all the problems we're going to be doing are from their book, and I'm just going to work through them. Hopefully, that shouldn't be something that's wrong. But anyway, and every day I'm gonna, well, not every day, but as often as possible, I'm gonna work through all of the problems in each of the math sections. So the best thing for you to do is, for the same section, do them ahead of time for yourself. Try to do as many as you can. Score your test, and then whichever problems you don't know, you can just watch on Khan Academy and hopefully understand them or re-understand them. So with that said, let's get started. So I'm using this book right here, Official SAT Study Guide. And I am starting on page 395. This is section 3, I believe, of the first math section. And this is page 395. So sometimes I'll write the whole problem, sometimes I won't. I'm going to assume that you have the textbook. So with that said, let's begin. So the first problem number 1, it says, if 2x plus 3 is equal to 9, then what is 4x minus 3? What is 4x minus 3? Well, this is just a very basic algebra problem. If you don't remember how to do this, you should probably review the level 1 and level 2 linear equations lectures that I have in the algebra playlist. But the way we do this, we can solve for x here. So we can just subtract 3 from both sides. 2x plus 3 minus 3. So you get a 0 here is equal to 6. And x is equal to 3. And so if you do 4x minus 3, that's 4 times 3 minus 3, right? And that's 12 minus 3. And that also equals 9. And there are some, you could have kind of done this a little bit faster, but this is the one way that you would make sure that you got the right answer. And on this test, it's B, 9. Move on. Number 2. There are 8 sections of seats in an auditorium. So I will write, let me do another color just to keep things interesting. 8 sections. There are 8 sections of seats in an auditorium. Each section contains 150 seats, but no more than 250 seats. At least 150, but no more than 200. So each section. So if we say S is seats, let me say S is seats. So seats are greater than or equal to 150 and less than or equal to 200. This is kind of seats per section. Hope I'm not confusing you. Seats per section. Which of the following could be the number of seats in this auditorium? So before I even look at the choices, you could play with the choices. You just have to figure out, well, what's the minimum? What's the minimum number of seats in this auditorium? Well, the minimum number is if every section only has 150 seats, right? So the minimum number is 8 times 150. 8 sections, each of them having 150 seats. Because this is the case in which every section has the smallest number of seats. So 150 times 8, 0, 40. 1 times 8 is 8, plus 4 is 12. So this is the minimum number of seats in the auditorium. And then the maximum number would be if we assume every section had the maximum number of seats. So that would be 200 times 8. That's easy. 2 times 8, so 1600. So we know that seats, let's say seats, is going to be greater than or equal to this and less than or equal to this. And what choice falls under that range? Let's see. 800. Choice A doesn't. It's 800. Choice B doesn't. Choice C doesn't. Choice D, 1300, does fit in that range, and we know that choice E doesn't fit into that range. So we're done. It's D. 1300 seats is a possibility. And we turn the page, and we have a graphical problem. Let's see what we can do with this. Let me clear image, red colors. Okay. Note, figure not drawn to scale. In the figure above. Okay, let me draw this. I think I'll have to just explain how it's done. I will use sky blue. This isn't. Let's see. So in the figure, so let me draw that line. Oh, no, let me do it better than that. Edit, undo. Draw a thicker line than that, so you can see it. So they have a line like that. And then they have another line that goes up and down like that. And then they had a bunch of points. So let me draw those points. I will draw them in a different color. So we have point A, point B, point C, point D, point E. And they call this horizontal line, they're calling this line L. And then, they have another point up here, point X. In the figure above, XC is perpendicular to L. So this XC is perpendicular to line L. So we know that this is a 90-degree angle, right? And I think they draw it. Yes, they draw that. Which of the following line segments has the greatest length? Oh, and in the figure, they also tell you the measurements of the different lengths. So they say from A to B is 3. From B to C is 2. C to D is 3. D to E is 1. And from C to X is 8. Okay. Which of the following line segments, they're not shown, has the greatest length? So the first choice, I'll write the choices down actually. Choice A is line segment XA. Choice B is line segment XB. Well, this is following a pattern. Choice E is line segment XC. Choice D is line segment XD. And then choice E is line segment XE. So which of the following segments has the greatest length? So if you just eyeballing it, you'll know that this XB is definitely going to be shorter. Whoops. XB, that was supposed to be XB. XB is definitely going to be shorter than XA. Right? Why is that? Because if you used, well, one, you could just eyeball it. I know it's not drawn to scale, but you definitely know that this length, this base, is longer than this base right here, right? So we know it's not going to be XB. We know XB is shorter than definitely XA, so we can cross that one out, right? Now, what we don't know, and we can do the same thing on the other side of I guess, this perpendicular line. We know that XD is shorter than XE, right? Same reason, because we know this base is longer. And if you use the Pythagorean theorem, you would know that this hypotenuse is going to be longer than this one. And you can review Pythagorean theorem and get familiar with the triangles if that doesn't make a lot of sense. But that tells us that it's definitely not going to be XD. And we also know it's not going to be XC. This is the shortest of all of them, right? And you could eyeball that. So it's either going to be XE, it's either going to be this, it's going to be XE or XA. And the way we figure out which one has the longer hypotenuse is we say, well, they all have the same height. So which one has the longer base? So this one has a base, this triangle right here, if we say this triangle, has a base of 4. And this triangle here has a base of 5. So this hypotenuse will be the longest. XA is the answer. I will see you in the next video.